So, you're interested in finding out if burning candles affect indoor air quality. I am too! So, why not work through some of the steps together? When conducting a research project like this, it's important to follow the scientific process. In order to continue this video, we all have to have the first 3 steps done. Start with a question, and gain background knowledge about respiratory health and indoor air quality, which you'll gain by participating in class and visiting some of these websites. If you haven't already gotten your background knowledge, stop the video and do so now, for there is no way that you can develop a hypothesis without first having a foundation on which to build. That information I used to construct my hypothesis, which is that burning candles will affect indoor air quality, but not to the extent and level of concern according to the APA standards. Okay, now we're ready to test the hypothesis. The air quality data I gathered, and that I'll be sharing with you, was collected using the DustTrak aerosol monitor. The DustTrak is a real-time portable particulate matter concentration monitor, which measures particulate matter in micrograms per cubic meter. The DustTrak pulls in air through a small nozzle and then records the concentration of the particulates. The monitor has logging capabilities, and its calculations are a reliable exposure assessment of the particulate matter concentrations corresponding to respirable sizes of 10, 2.5, and 1.0 microns, or PM10, PM2.5, and PM1.0. In this experiment, we chose to study PM2.5. So, I chose the nozzle that measures particulates 2.5 microns and smaller. PM2.5 is of concern because particles of this size have the ability to bypass the body's defenses and travel deep into the lungs. Before conducting any real experiment, I always remember to put on my lab coat and goggles. Because as you know from your own experiments, safety first. I placed a DustTrak on a counter approximately 3 feet from the ground because 3 to 5 feet is my respirable zone, and it most closely simulates human exposure. The DustTrak is also a few feet from the candles because that gives the emissions a chance to dissipate and also gives the DustTrak a more accurate reading of the sampling site. In the first experiment, I tested with a wooden match to light the candles. I programmed the DustTrak to turn on at 2000 hours and turn off at 2200 hours, and during that time, I blew out the candles and relit them again with a wood match. In the second experiment, I used a clicker igniter to light the candles. I programmed the DustTrak to turn on at 1959 and turn off at 2154. Also during that time, I blew out the candles and relit them with the same igniter. Okay, now you've seen what I've done to test the hypothesis. Step 4 of the scientific process. Now you're ready to move on to steps 5 and 6. Analyze results and draw conclusions, and establish the accuracy of the hypothesis, and decide if more experiments need to be run. To do this, you will need the 5 pieces of evidence from the candle burning electronic notebook. The first piece of evidence is the sampling survey, in which I will tell you all the conditions of the sample site, including the, say the dimensions of the room. And the second piece of information will be the data set I ran in the first experiment using the wood match. Your second or third piece of information will be a graph that you will make of the first data set. Then the fourth piece of information is the data set I downloaded from the DustTrak when I ran the second experiment with the ignition lighter. Your last piece of evidence is a graph that you will make with the second data set. Now you're ready to run off and do steps 5 and 6 on your own. Once you've finished doing this, ask your teacher for the second follow-up video in which we will compare your results with mine. All finished? Let's see if your conclusions match mine. In the first graph here, it has my first data set with the wood match. My second graph is made with the second data set with the igniter. As you can see, with the wood match here, we have about 6 spikes. Using your activity log, can you explain these spikes? Now, back to the igniter graph. Using your activity log, can you explain stability here, the spike there, and the spike here? Can you tell using your activity log and the graph when I lit the candle, when I blew it out, or even when I brought my cat into the room? Also, from looking at this graph, it seems that the particulate concentration was much higher. But when we compared this spike, which equals about 0.3 milligrams per cubic meter, to this graph here, which ranges to 30 milligrams per cubic meter, that spike only levels around here. So, what does that say about each experiment, using the wood match and the clicker igniter? What conclusions did you draw? And now we're ready to move on to step 6 of the scientific process, since we've already completed steps 1 through 5. In step 6, we will establish the accuracy of the hypothesis. My hypothesis was that burning candles would affect indoor air quality, but not to a level of concern that exceeded EPA standards. But in fact, when I analyzed my data, I found that at points it did exceed EPA standards, in which case my hypothesis was not supported. Since this is the case, and being the inquisitive person that I am, I have decided to isolate 2 variables, the methods of lighting the candles. So in this case, we don't even need this anymore. In this new experiment, I would set the DustTrak to run, and then after 10 minutes of air quality sampling, I would light my first match for 5 seconds and then blow it out. Then, after another 10 minutes of air quality sampling, I would ignite a flame using the ignition lighter for 5 seconds, and then release to let go. And then, thirdly, after another 10 minutes of air quality sampling, I would light the match for 5 seconds, but this time extinguish the flame with water. My new hypothesis is that by extinguishing the match with water, the particulate concentration would be much less compared to the first test, in which I blew out the match. Finally, I worked on the last step of the scientific process: share findings with others. I made this brochure to help educate people about respiratory health and indoor air quality. Now it's your turn to decide how you'd like to share information with others. Would you like to make a brochure too? Or maybe you'd rather write a persuasive speech, or a PowerPoint presentation, or even make a poster. All of these are great ideas and strategies in sharing scientific information, an important part of scientific research. After all, at this point, you now know more about air quality, respiratory health, and particulate matter than most people.
Air toxics.